turn that down a little bit. We'll get started here soon. Hey! Glad to see you on here. I know we'll probably have a lot more people in here than we have for the past few sessions. Hey, what's going on, man? All right. Well, I guess I should probably start. So, continuing where we left off, in the last session that we had, I don't think I think we'll have some new people in here, but the last two videos are up on, or last three videos are up on the YouTube page, and that is on the link on my Twitch. So if anyone wants to go and check those out, you can. Do a flip. Yeah, I'm a little confined, so I don't think I'm gonna break anything. It already took me a while to get this set up, so I think I'll pass. All right. So where we were with the last session, we just finished up with the I believe the unicorn coloring book or Pegasus coloring book, trying to get that to work, and now we're going into character physics. So now we'll be able to make our guy, our little Cody, be able to jump around and be able to have gravity actually affect them. So, for example, right now, I'll start this over, but you can see right here that the bugs now have physics on them. The little Cody here is sitting on top of this area and has physics on him, and you can even see the collisions. So once this interacts with this bug interacts with Cody, then it puts up a game over. So, all right. So hopefully by the time we're done this, that should be able to do it should be able to do it from always finish it or be able to learn how to do that. All right. So I'm gonna go on and let's get this one started. So first things first. So we have our sprite right here, which is the bug. And now, if you notice now, whenever we create the sprite, we've had this this dot add dot sprite here in the create function, but now we're actually adding, if you notice, another argument for physics. So the first argument sets the x coordinate of the sprite center, as we know. The second argument is the y coordinate, and then is the key image loaded in the preload function. So up here, as you know, you have your bug 1, bug 2, bug 3, your platform, and then here we have Cody, and these are all loaded in here. And then we'll be adding them down here into the create. So let's look at the conditions on what we need to do. So within the create, we're going to create a new sprite and add the physics, and we're going to use Cody. We're going to add Cody in here. Okay, so we will go ahead and this dot physics, so the new physics we want to put on Cody. All right, so dot add dot sprite, and then we have our x coordinate, so where we want to put him, so we'll do 50, and then we want him to be somewhere down here, so we'll do 400, and then we want to, as you remember, get Cody, so put Cody in here. All right, so we'll go ahead and run that, and notice when we add that physics, he now drops down, whereas when we didn't have physics before, he would just stay in position. So now it'll keep him solid on the ground, and we'll be able to get him to jump later on. So observe how it's affected by the game's gravity. Okay, so I guess we can make him a little higher. Let's start with 0. Well, that'll put him all the way over here, so we don't want to do that. We can still have him at 50, but let's put him instead, change the y coordinate to, let's put that at 50. So he should pop up here. And there you go, see? So you have your x, which is on the horizontal axis, and then you have your y, which is on the vertical. So let's put them back at 400. I guess it really doesn't matter. But there you go. We have physics on our objects now, on our sprite. So let's go ahead and go to the next one. So now we have to implement the physics. Sprite carried away by our game's gravity. This is the use of physics plugin, which decides how game objects interact with each other. I'm going to use this Phasers Arcade Physics plugin. Alright. Plugin is great for adding gravity to our game and detecting collisions. Okay. So in the configuration, we add our physics. Default is the arcade. Alright. Then you have your arcade, adding the gravity, and then your debugging. Okay. So let's go, I guess, over each of these properties. You have your default value of arcade, which tells Phaser to use the arcade physics plugin. Then you have your arcade, another object that contains details about how we want the arcade physics to work. Then the arcade object has 2 keys, gravity, which is set to 300 Y, and then to assign a downward gravity. So instead of putting physics to just so instead of having physics on just one of the objects, it should put it on multiple objects. So value 300 is based on peripheral preference. The higher the number, the stronger the effects of gravity is. There you go. So debug with the value of true to see the outline of objects in our game and their velocity. Okay. So you get to view how fast they're going. We call physics.add sprite. We'll actually tell Phaser's physics plugin to create our sprite for us and have this sprite follow the physics of the game. Okay. So, yeah, this is the physics for all the objects. The config object, so down here we're going to finally add the physics plugin. Okay. And within here, we're going to set the default to arcade. And then arcade. Okay. Alright, then we're gonna add the gravity with the value y of 300. Okay. Yep. And then debug set to true. Now that we have physics in our game, we can run comment. Okay. So add sprite, Cody. All right, let's go ahead and run this. Ah, there's the debugging. So it adds a box around it. Okay. Let's see if we did each one of these right. Yep. Looks good. So we have the scene that does the preload, create an update. Then you have your physics. Your default would be arcade. And then defining arcade with a gravity of 300. So if I wanted this to be higher, we could do 500 and run that. Adds a higher gravity to that. We can even do 1,000. And run that. There you go. Okay. All right. Nice. Okay. So adding static groups, so I would assume this would be the platform, so he's just not falling through this stage each time. We'll go ahead. Get that player sprite to land on some steady ground. Right, need to create the platform. Okay. So we gotta create a variable called platforms and then add physics to it, but as a static group. Okay. create a group object which keeps track of our platforms. So you can make multiple platforms, but for each one of those, if there's multiple, so if there's multiple objects of the same, you can keep track of them by making multiple objects. And then if we wanted to write a script or we wanted to use a command or something to tag all the platforms, we can. Okay. So the sprite center, the x coordinate of the center and the y coordinate of the center, and then the image. Okay. So need to add our platforms. So we're using a const variable, which means that this can't be changed once it's declared. So platforms equals this dot physics dot add dot static group. All right, there we go. And now we need to actually add our platform. So let's go ahead and run this. So it shows that this is done. And then it wants us to create on the x coordinate 225, and then on the y 510. Okay. So we'll go ahead and let's do that. So we'll create our first platform. So platforms dot create is part of the group, and then it wants us to create 225, 510, and then we need the image of the platform of what it to look like. So we're going to grab that key for platform. All right. We'll go ahead and put that platform in here. All right, we add that in there. Now it doesn't have a collision, so when that object collides with this platform, we want it to be able to stand on top of it. So that'll probably come in maybe the next lesson, maybe the next couple lessons. But it's there, it's going across. This is the width, the X. Here's the Y position and the platform. And I mean, we could put this really anywhere. So if I were to do like 50, like we have been, see, we can just put it wherever on the sides or anything like that. So it doesn't always have to be right here. But I'm gonna go ahead and put that back. All right. So let's go to the next lesson and see. There we go. Detecting collisions. So right here. So we have your platform, right? We have the player, but they're not interacting with each other. Right. So we now have to add a collider. So as you can see, for the this physics.add, and then you have to add the collider for them to kind of have friction against each other. So, all right. So as you can see, this one in this example, you have the player, and then you have this platform. So this just adds it always that there'll be a collider between these two. So we can do that too. Let's keep Koei from going off the screen. Oh, okay. So from here, so the player and the platform don't overlap if we do it this way. Now, we can call the set collider world bounds. Okay, true. For the game object, we want to stay inside the screen of the game. Okay, so that way he's not constantly falling out. So cool. All right, so we'll just go ahead and there's the game state. All right, so we have a const, the game state. Then you have these of the player. All right, so we want the game state. So it's the game state, if you want to think of it, is just like the generalized controller. So we want it to not, what is here, the player? Okay. So we want to get the player, and then we want to dot set collider, or set collide world bounds. Right, because you don't, okay. So yeah, you don't want to put it on anything else. You want him to stay on there, so we're gonna set that to true. Okay. Game is not defined. Ah, oops. There we go. Should be right there. All right. So technically, he is staying in here. He's just hidden behind this platform. So underneath this, we have to make sure that we declare that Cody and the platform will collide with each other. So physics.add.collider, and then we have to tell it that we want the player and the platforms. Okay, so what is happening here? So this dot physics dot add dot collider. Right. The game state is stored within here. Right, so I have to declare it this way. There we go. Nice. So now we have our little guy sitting up on here. So we've learned about the static groups, and that we can make tons of items based off the static group. And then off these static groups, we can create an instance of each one. So I can make like 15 platforms of different styles, and each one, the player will collide off of each one of those. Cool. So we are actually nearing the basics of each of the games. I need to see something real quick. Need to look at this. Clear everything out. Okay. Just set that back. All right. So let's go on to the next. Adding controls and velocity. All right. So Now, if you remember, we have to add the cursors or else we won't be able to get it to move. So let's go ahead and get that going. But before we do that, let's see if there's anything extra going. So create function, create the cursors object. Yep, the create cursor keys, and then the update. We tell it what we want it to do if a cursor is held down. But now we have a set velocity with an argument of 160. Especially if we set the horizontal velocity, set velocity x. So now we can tell it to go left. So there's a set velocity x and set velocity x. So now we don't have to keep doing, well, we'd still have to do the game state. A 60 moves the sprite to the left. The opposite happens when the right arrow is pressed. We call set velocity positive, right? So one is left, one is right. It moves the right. Okay, so we have the player. So, alright. So like we did previously, we gotta set up the cursors variable, or add the cursors to the game state object. So game state.cursors, we're then officially adding it to the game state right here. So cursors, so this dot input dot keyboard, and then dot create cursor keys. Here we go. So now that's done. Now let's do our if statements. So if game state dot cursors dot left is down, we'll go ahead and make the player dot set velocity x. So if we're going left, then we're gonna have to go, we want it to go 160. How much does it actually want? Okay, so 160. Alright, and then we'll do an else if. So the player dot set, oh wait, oops, I gotta define the else if. So we need the game state dot cursors dot right is down. Oh, didn't mean to press that. So if the right is down, we'll set the velocity to 160. Oh, and we gotta make sure to declare X. That's doing that. Okay. So if there's nothing, then the velocity should be 0. So, okay. So, seems we're on the right path. So, if not, if the player isn't doing anything, then we're gonna set the velocity to 0, or X to 0. That means nothing's happening. So we'll go ahead and see what happens. Alright. Add new statement to check. If game state cursors, yep, dot left is down. Okay. Yep, so in the if statement, to check if the left arrow key is pressed, which is cursors, dot left is down. Wait a minute. Do I have to actually... I might have gotten too ahead of myself. Hold on. No, we want the player. Oh, wait a minute. Huh. Okay, hold on a second. Player dot set velocity x. There we go. We just put the player. I don't think we put the game state, I believe. And we did not. Because the player is part of the game state. It's not a variable on its own. There we go. So we'll run that. There we go, that's why. I thought it was because all this was here, but apparently it's just because of that. So, as you can see, we can now move across left and right. Across here. And this is just using velocity, so it's not how we would do the game state.player.x and then setting that plus equal to, you know, 5, like updating the position by 5 each time we press the arrow keys. Instead, we're actually setting a velocity. And that's how we're determining how fast it can go. Yep. Okay, so if nothing's happening, then it will stop doing what it's doing. Nice. All right. All right. So now this is done. We've learned about saying the velocity, and we've implemented the controls. So set the scale. So I'm looking at this one, and this is a new one where it says set scale. So I believe it's setting the scale of this and cutting it, I believe, in half. So that way it's appearing smaller than what it usually is. So if I were to just, you know, wow. Oh, that's a 0.1. So if I just put a 1-to-1, yeah, okay, so it's 1-to-1. So how it's 1, if we put 0.5, cutting it in half, and then obviously if you put that 0.1, it's going to be extremely small. Okay. We'll go ahead and go to the next area. All right, so now the next crucial part in these games is finally adding an enemy sprite, which would be the bugs. So we're going to be adding that to group, another group. They're not going to be static though, so instead of it being a static group, it's just going to be a regular group. We're going to call it enemies. Alright. And when we create our enemies, so these are just the group, but you can create each enemy and use which key you want to use. So, seems relatively the same. But with our current code, we know that our enemy will always appear at this coordinate, and that's not much of a challenge. Correct. Instead, we can randomize where the enemy's x coordinate is using math.random. Okay. Returns a so math.random returns a value from 0 to 1. Okay. When we multiply the value of math.random with the width of the screen, we get a value that is between from 0 left hand side to the width of the game, the right hand side. Okay. The product is a random x coordinate that is always on the screen, right? So you have your physics group. You then declared an x coordinate of where it will appear above from here to here. So remember, this is essentially 0, 1, and you want to times it by 450, which is the width. Then you have the enemies.create. And then for the x, you put the x coordinate. You want it to start at 10 for the y, and then with enemy. Now, I think I would be a little bit higher than y, than 10, so that way you're just not seeing it appear every time. I would, well, we have to see what it would actually do first. So we see that it's always in the crate. So if you're wanting to do this for so many different enemies, we could then create our own function called the generate enemy function, and then we can just do this, and we can call this like as many times as we want. So with our update code, we can create an enemy sprite every time we call generate enemy. Yep. So first, let's create the enemy. So const, we'll do enemy bugs. Okay, enemy bugs. This dot physics dot add dot group. That's what it was. So it's not a static group. All right. So now we have our enemy bugs, and then we need to create a function, and it wants us to use bug gen. Name bug gen to generate our bugs. And then it wants us to do, so we don't want to change this, so that's also going to be a const. So this doesn't change. So we'll do, what is it? X. So X coord. Oh no, oops. X coordinate. Okay. And then we want it to be the math dot. Oh my gosh. Random. Math.random. And then we want times this by 450 by the width, as you remember. Believe. Yep. And so then we want to generate the bug. So we'll do a, what is it? Enemy bugs. And then create. And then we want to put the X, for the X coordinate, we want to put the X coordinate for the X. And then remember how we were saying for the Y, how I was kind of not wanting it to be exactly 10. I'll probably put it a little bit higher. So why don't we do -10? So that way it just, you know, we don't know where it's coming from. It just starts coming down. That'd be pretty cool. So, and it wants us to do bug 1. All right. That's what it just wants us to use, the first bug from up here. All right, so let's go ahead and run this. A variable called bugs. Is this what we're gonna call these? Okay. I've now created that. So define the empty bug gen. We did that. Inside bug gen, create a variable called x coordinate. Assign it to math. We're case sensitive. So this can be uppercase, but this one right here specifically, this has, since this is a function from a separate library, this has to be match exactly. So now when we run it, should have came down. Yep. It's probably gonna hit me because it's not exactly -10. When we did that. You can, oh, that's right. I named it enemy bugs. I remember. That's right. Okay. And now we have to actually call the bug gen because there is nothing here. So let's do, now let's go ahead and let's call this, so bug gen. Now we're gonna generate our bug. There it goes. So instead of doing that, what's what we did for the previous idea and see how that works. There we go. I kind of like that better. And we can, and the greatest thing is we can do this numerous times. So if we want to do 3 of them, we can. So let's spawn 3 bugs. Pretty neat. So, all right. Now that we have 3 bugs, look at all the code that has been written so far. Seems like a lot, but it's really not. Because a lot of the times, you can separate functions out. But most of the time when you look, they kind of look like this. Kind of looks like this. Unless you're wanting to separate it out. Like you have a thing for cursors that's separated. But everything that is usually together, like this player collider bounds would be true, and you can put this on top up here. So it would look like that. In a typical coding scenario, they kind of group them together. So you have your player stuff right here, your platforms right here. Then are adding that the game state and the player and the platforms both collide with each other, and then your cursors, and then usually you would have your comments and stuff, basically saying what each area does. But we're gonna go ahead and go on to the next one. But so far, like I said, what we've done so far is we have now created the enemy bugs, and I'd imagine our next step would be to giving the bugs a collider. So when the bug collides and hits us, then, you know, it would end the game. But we also have to think, you know, how can we keep spawning bugs until, you know, it hits us? So that'll be another thing. So that would probably be a while. We'll have to use loops. So it just keeps on doing it and over again until, you know, a collision with the bug and Cody or our player comes in contact with each other, and then the game will freeze. I believe the bug's velocity will go to 0, and it will stay still. So we'll have to see what happens next. So let's go to the next area. All right, so we have timed events. So I believe this is what we were talking about with, you know, those dropping down over time. So currently our game creates a few enemy sprites and stops, but we could create a loop to consistently create more enemies to make the game more challenging. Right. To implement this loop, we call the this.time.add event and pass an object with specification for how we want the loop to run. Okay. So code to generate an enemy sprite, so this is how it is, but then you have your loop right here. So this dot time dot add event. So you're putting the generate enemy function, so the one that we made. Oh, well, it looks like it got rid of it, so we'd have to probably create that again. No, there it is, the bug gen. So we put that in there. So let's go ahead and add one of these events. So in the create, under bug gen, so we'll do this. Const, it's going to be, oh, it wants to do with this. So it doesn't want us to, okay. So we're not going to assign it to a variable? Okay. Means the event will call generate enemy function, right? The delay, okay, has a value of 100. So, all right, so it calls this and then delays it by 100, which that is in milliseconds. So it's 100 milliseconds, then another one happens, and it just keeps doing that. Callback scope has a value of this, which selects the scene this event is used in. So it'd be used within the scene right here that we're currently using. I believe in the create. Yeah, I've been doing it for quite a while. Mr. Simpson. Just you kind of get bored doing it by yourself for so long. It's good to have other people to be able to talk to and, you know, enjoy it as well. So, anyway, what I was saying was the delay is 100. The callback loop. This would be, the callback scope would be would be in for this. So the scope that it's happening in is within the create, and then the loop is true, has a value of true, which means that this event will continue to execute until we remove it. So I'd have to remove. So what would happen would be is if an enemy collided with us, then we would have to remove that loop and set that to false, so no more enemies would generate. Or we would have to stop it, is what it seems like. So we'll figure that out later. But right now, we will go ahead, see what it wants us to do. So it doesn't look like it wants us to assign it in a variable. So we'll just go ahead and call this .time .add event. All right. And then we want to do what we're going to use. So now I gotta look. The callback. I gotta remember. That's the thing I just gotta remember is each individual one of these. So we have our callback. So we have our callback. We have our delay. Our callback scope. And then we have our loop. All right, so we're gonna make this true. Our callback scope is going to be this. Our delay, 100 milliseconds. And then our callback, we are going to use the bug gen. So it's going to call this each every 100 milliseconds. So we'll go ahead and run. All right, where are we hitting at on here? It wants us to do 150. All right, thank you for the follow, Stivus Arrow. All right, so now we're trying to figure out. We did the this.time, add event, a callback for bug gen. As we can see right here. I'm trying to see where that is not working. Okay. It's under bug gen. This.time.add event. Okay. Hold up. Wait a minute. I might have. Okay. So in here, we didn't put it inside here. And that's why. Because it's not a function. We have to add it into there. There we go. So technically nothing was happening because it wasn't actually inside this add event, inside these parentheses. So that's a good thing to know. Is you gotta do the scope. Oh man. I think I have a feeling I know who that is. That's awesome. Pretty sure that's Ian. Okay, we'll go ahead and run this now. There we go. So as you can see, every 100 milliseconds, it is recalling this loop. However, it can keep hitting us and nothing will happen. So we have to kind of change that. I'll tell you, man, that was a really good time. Tell you, I miss the mountains and stuff. And around Indiana, all you got is corn. Okay, so as of right now, we got it going. So does it just not like the fact that we have all this other stuff in here? And it just wants us to do this one at a time? I'm gonna call this time event assign. Oh, is it supposed to just be empty right now? Okay, hold on. Maybe I gotta remove this. It's very picky. I don't get what it's... Oh, okay. Right, duh. So we got to assign it a const. Is it an actual no. I think, wouldn't it be a let? Okay. I guess it just doesn't want it to be changed at all, so we'll just go ahead and do a const and bug gen loop. And we'll assign it to that. Me too, man. Yeah. I'm sure Oregon is pretty nice where you're at out there. There we go. That passed. Add an event. And that should pass as well. Cool. Yeah, I was wondering why it just wanted this. I thought it would be assigned to an actual variable. There we go. But yeah, you know, I would, but you know, having the kids near family is important, so, or at least relatively close, and couldn't take that away from them. So we'll probably be here for at least a while, unless something major changes. Or if, you know, job-wise, something I can't pass up. But yeah, I'll have to definitely take a few trips in the future to probably go back out at maybe some point. I know, definitely want to go back to the ocean, probably up in Maine, or you know, maybe over in Virginia. Yeah, maybe Oregon sometime. That's a long trip though, especially with the kid. But yeah, we'd have to definitely plan on that. I'll have to think about it. Tell you, life is busy. But anyway, we got this working. And I think the next step we'll have to modify the collision. Ah, there we go. We have to remove it. So after it goes through this area down here, we have to make it destroy. Or, no, when it hits the platform, then destroy it. But to remove the enemy sprites from the game. So when it hits the platform, we want it to be destroyed instead of going through. Man, believe me, you know, I always have a smile on my face if, you know, I get to see all my friends. We'll definitely have to game sometime here soon. I've actually been playing, me and my wife, we've been playing Fortnite lately. Mostly on zero builds. Yeah, we've been playing zero builds. We're not very high in the next season. We haven't really played too much yet. It's pretty fun. We got some people that we're friends with that you sometimes hop on. All right, so to get through this, consider what we want our enemies removed. For a game, bugs should disappear when they hit the ground, right? So the ordering of the collider with 3 arguments. First, the enemies and platforms. The third argument is a callback function that has a parameter single enemy. The ordering of the callback function's parameter corresponds to the ordering of collider. First 2 arguments. We call single enemy dot destroy, which will remove the enemy sprite when it collides with a platform. So the third is a callback function. Okay. So I assume function single enemy. So would that be the... No, because that's the bugs. Oh, it's creating this function. So it would be single enemy dot destroy. So okay, it's making its own function right here. And it would be the bug dot destroy. Okay. From Fort and gave up. Play Apex for a little bit, getting too old to be competitive. Yeah, I feel that I'm definitely becoming a lot more casual game, but you know, I think I like the fact of, you know, working with teams and just being able to... Oh, I guess I have to stay competitive to really enjoy it. But I have been playing a lot of single player games lately. Like the other day I just beat Shadow of the Colossus. And I haven't been able to beat that, you know, till just now, just because I get too distracted. Okay, so we want to add another collider with this. So we have the bug generator. We created the bugs, created the bug generator, create a loop that calls the bug generator, and then we will do a this dot create the collider. So this dot physics dot add dot collider, and then we add, what do we want? Okay, so the collider, we have the player. Oh, we have the player, and then we have the bugs, and then we have a third argument for the function, and I believe that we're wanting to pass one parameter of a bug in here, add semicolon, and then bug dot destroy. So when this collides right here, when the bug collides with the ground, it should disappear. So we'll run that. Nope. Is this a physics.add collider? We have the player. Oh, because it's not the player. It's the platforms. Okay. And it has to be in that order. So, oh, the bugs colliding with the platforms. It can't be obviously the platforms colliding with the player. So there we go. See, now they're all disappearing. I hope you're doing well, man. Yeah, I haven't talked to you in a while. I'm glad to see you came out and watched. But yeah, we gotta play something sometime. I've been doing a lot of mobile games lately. Just kind of testing a lot of stuff out. I tried Albion. I never really got too much into it. But yeah, it's been a lot of casual gaming. You know, taking care of the kids and playing with them. And you know, then by the end of the day, after they're all in bed, you know, it's kind of tiring. But this has been a good thing, interacting with other people and being able to actually enjoy programming and doing kind of the stuff I want to do, because after working all day, you know, you're really busy and you can't really do all the things you want to do. So it's a good pace. Okay, so we did the collider bug and we did the destroy. So we'll go through each of these and unlock the next step. Awesome. So I think the biggest challenge is when we start creating our own game is remembering all these little steps, and it's gonna happen. We're not gonna remember each one of these things, and you know, it's good. That's why we have this learning group to be able to kind of ask and see if they remember. And you know, you have the documentation if you need to, you know, go ahead and add your players and, you know, your enemies and, you know, your static elements like your platforms. But right now, this is like a big good grounding to get all the aspects of the program. Alright, so what's our next one? Okay, adding score. So I assume how we're dodging here, we'll be generating the score. And to have the score element right here, I believe there it is. So we added a score, gamescore.text now. That's part of this game state. And then this has the text right here with a score of 0, font size, fill color. Okay. So I believe when there's destroy, when it collides with this, it also adds a modifier to the score to like add +1 or +5, whichever one. So it wants us to start with a score of 0. So create, we would add here, right? Right, so it's going to add +10 to our logic. Okay. So what it's doing now is it's going to get the game state, and then we're going to access the score text right here, and we're going to update the text to set the text to this, to the new score whenever it collides. So we'll just go ahead and set this to 0. So we'll add our score property into here in the game state manually, and we'll set this equal to 0. Then when it collides here, we want our game state dot score now plus equal to 10. I believe that's what it wants us to do. And then we have to update the text. So the game state dot score text dot set the text, and we want this to be score equal, and then since we're entering the variable right here, or is that the second argument? Yeah. Ah, that's right. We have to add a tilde. Because we are putting a variable inside here. So instead of putting it just like a string, if you put a tilde inside here, this will actually let you put this character here, and anything inside here will actually use the game state dot score. It'll actually use a variable, so it'll say score here. So let's keep adding 10. So once it's destroyed, oh wait a minute, does this have... We did that. So we add score. Oh. Duh. It doesn't... In the objects, you don't put a semicolon. Okay. I was sitting there, I was like, what? Okay. There we go. See? Now you can see every time that it hits that, it brings up the score and adds a 10 each to here. Alright, so this has to stop obviously eventually, so we're probably going to have to add, eventually we're going to have to add a collision with our player. Alright. Okay. So we did the crate inside. Did this. Alrighty. So what we did, just like a recap, we added the score in here, we added the variable and set it to 0. Then we told the computer that when this collides, we get the score and we add 10 to it. Now, if you haven't seen this before, again, it's the same as game state dot score plus 10. So it's the same exact thing, only this is shorthand. So we don't have to keep writing that out each time. We can just do plus equals 10. And it's the same thing. Then the game state, you got your score text, and then you're setting our text to be the score, and then accessing the game state score variable property in here. And once this keeps adding, that's how you get our score. So, alright, I think we're good on that end. We'll go ahead and add next. We're getting near the end. We're now at a 11 out of 13 for this. So we need the logic to end the game. Alright, so now player, enemies, logic to end the game. Alright, so we could call destroy on the loop, that creates our bugs. Want to stop is the physics of our game. Put pause on physics, we call this .physics.pause. Okay. So that makes it even easier. We can just pause all the physics at once. Now, here's the thing that we're now seeing is this right here. So instead of declaring function this and then adding this, function in the parentheses and then adding our brackets, we now have just an empty pair of parentheses and then a pointer. And this is what we call a pointer function. So notice the use of an arrow function for a callback instead of an anonymous function. The reason for using an arrow function is that it implicitly binds this. We know we want to call this .pause, and we need this to reference the scene object. Therefore, we'll use an arrow function. Okay. And yeah, it has a arrow function documentation here. So this right here just basically says this. We can look at this a little bit more. So you have all of this right here. Arrow function and the traditional functions don't have their own bindings to this. Arguments are super and should not be used as methods. Right. Okay. So this is what we have, right? Move the argument parentheses. So we have essentially this right here. So it's just basically a function without having to give it a name or anything like that. Yep. And it just implicitly calls it. Okay. So we'll add it down here. So this dot physics dot add dot collider. Okay, and then we're gonna say that the bugs collide with the player, and then we're going to add the arrow. You know, this makes me wonder how this would work if I just... I believe this should do the exact same thing. Yeah, so it essentially does the same thing. So you could use either or, but I'm gonna keep it that way. So anyway, remember we didn't create our own variable with that. That's stored in the game state, so we gotta run that. Okay, so it wants us to, for the game's player, wants us to do it this way. Empty, throw back. Okay. Into the game state player. And the bugs. And then you have an empty pointer. What? So gotta chill. Bugs. And then we have our empty arrow callback function. Okay, it is empty. What? I need to figure out what I'm missing here, because this dot physics dot add in the collider. What? I know. I know I'm forgetting something here. Bugs. That is exactly the logic. What? I'm using. Like that's it should be the correct syntax. Am I missing something here? I got the first parameter, second parameter, and then this is the third for the callback function. But I'm not. Alright. Give me a small break to use the restroom, and then we'll come back to this. Alright. Oh. This cord is in the way. Hold on. Alright. Just have wires everywhere. So wish I could see where the fault is lying. Apparently it's not there. Let's go ahead and just reset this because I'm trying to figure out where that even... Alright, so that's there. I don't know exactly where it was, and it's hard to determine where it is when you don't have an editor. But we got that working. So we want to do... We want to stop the the bug gen loop. So that's running right here. So loop. So we'll destroy the loop. So see, it hit me, and then the loop got destroyed. So we also want to this dot timer dot pause. Is that what it was? I believe. Or is it time dot pause? This physics dot it's physics. So we'll run that. There we go. So we got 40 points. And then I believe, like it says, we are going to add a text. I'll say, be at the corners of you choosing. So, where's to show the game is over? The text should be corners of your choosing. So this dot add dot text and 200 saying game over. Font size, no, would be font 15 pixels, and okay, and a fill of white. So, or is it, no, that would be black, I believe. So oh, there it is. Game over. Well, as you can see, it does say game over. Font size of 15 pixels. And the fill should be. Ah, that's why. What is lower? It's because I didn't put it exactly the way this wanted it. Even though it still showed. There we go. Yeah, because these... Okay, these are CSS and these are case sensitive, so they have to be exactly the way they're supposed to. So game over. Let's move it over a little bit. So let's say like 175. So it collides. That's not in the middle either. So let's look at 450. That'd be 225. The size is 450. No. That's fine. We'll keep it right there for right now. There you go. So we have a game over now. Score, we stopped time. And if we want to, we can actually make this go faster. So if we want 500, the gravity, look how fast it's going now. Yep, and since it stopped, the score's at 520. But we can move that back to 200. There we go. Alright, so what's the next? So restarting the scene. So like if we see, clicking to restart. See, we need to detect on the pointer up, right? Calling. Okay. So add text, and then we add a click to restart so we can tell the user, hey, if you want to, you're gonna have to hit the button. So let's go ahead and move this dot. Put dot on. pointer up. And then we could use a function, or we can just do another one of these pointer functions. Instead of anonymous function, we can do on the pointer up. So this dot, where is it? Oh, okay. So we put the game state dot score, set that back to 0, and then restart the scene. There you go. Yep. There we go. So it restarts the whole scene and resets the score back to 0. Because we don't want them to keep the same score. But I know probably pressing that button over and over again. So we can add this pointer up function. But can we also make a this dot input dot on would be key down and then enter. Can we do it like that as well? Nope, nope, nope. Yeah, could you just do the same thing if we do a, or is it key pressed? Nope. Can't remember that. Key press. Phaser 3. Whippy. Don't want to do that. Whippy dot imp. The keyboard. Do we have to set the keyboard? Add key. Phaser dot keyboard. I don't know if this is the actual. Game dot add. So this dot input dot add key. The phaser dot keyboard dot. Okay. I'm trying to see if I can add a keyboard press into this as well. Uh-huh. Dot input dot keyboard dot on. Yeah, that would make sense. Right, because we have the keyboard. And did that say a key down? Nope. How do we do that? Oh. So like if we use the W key? Oh. Okay. So what if I did... Starting to come back to me now. Enter. And I get hit. Ah, the enter key. Let's try this. Nope. Got this enter right here. Try run that. So if it hits, what the heck is the enter key? Dang, man. Huh. So the enter key on phaser 3. Where is the enter key? Yeah, I get that. There's W. So you have W. Wait a minute. Ah, enter. It is enter, but I did not put it right. I think it has to be explicitly all capitals. So if the key down is entered. There we go. So the enter key is now being pressed. So we can do that, or we can click. I should have known that because the input, this is for the pointer if you have your input. This is the keyboard, so of course. Alright. So we'll go ahead and do the next. Review. Nice. Change the delay, the property game to make more difficult. So we could also define an if statement in here, like within the create. So if, well, I could even do this, where you update. I could say, all right, if, so if, I don't know if that will transfer. Okay, the game state is outside the create, so it's a global variable. So if, okay, so let's do this. The game state is, oh no, dot score is greater than or equal to, let's say 1000. Then we'll go ahead again. State. Wait, hold on. The delay. We can't change the delay, can we? We could change the volt. Dang. Couldn't do that. Unless we know the syntax for delay. And I really don't want it to be extremely long. Okay. Well. Check for a spacebar input and make the player sprite do something. Like jump? Well, I'm gonna get rid of this one because I don't know too much of the syntax to do that just yet. I'm sure I'll go over it. If not, we can always implement that into when we actually create an actual game. Make sure the player sprite do something. Well, I don't know if I want it to jump. And there's probably a call to make it jump. Okay. Alright, so we just got through the lesson. So if you have the pro version, the next one would be a quiz and controls, basically to check how well you know the material. But then you also have this Bug Invaders project, which obviously is the pro. Now I didn't show you this, but they do have plans on here where you can get the annual, do a white annual, monthly, or whatnot. But when you look at these, you gotta think if these annual, you have to pay it all in lump sums. This would be a monthly right here. So there's plenty of material though that on the internet that you don't have to get those things. You can go from this to a YouTube video. You can find like on Udemy if you want to continue that way. There's many other routes you can take other than paying for that much. But the free version, as you can see, gets you a very well-defined, at least fundamental idea on how to create these things, and we've already created a decent amount with just this. So when we start going to making our game outside in an actual text editor like Visual Studio Code, we'll be able to do more. All right. So I don't know. There's only 6 for this next section, and this is to make multiple scenes. So you can go from one scene to another. So like in the platformer, like if you hit a door, it'll take you to the next scene, and when you hit like, you know, a portal or something, it'll take you to another scene. And then when you're done, like let's say in the Mario games, you know how you go into like a warp pipe and then you come back to the main scene. That's basically like what this is doing. As you can see, upon event handler, like upon the condition, it'll stop the scene, it'll start the next one, and then it'll stop that one and go back to the previous scene while still maintaining your score. So look over the different files and how code is organized, then click on the game to transition to the scenes in the browser. Same logic to our code layer exercises. So first scene, second scene, third scene. So let's look. So the class, scene 1, is extending phaser.scene. So this class is like, so how do I put this? Is like a bunch of different or different boxes. So you have classes for different things. Like you can have your main class, you can have a class for all your objects, you can have another class for all, you know, separate rooms. Like, so what it's doing is this class, the scene 1 that we're in, is extending this library, the phaser.scene, is extending that object, or it's extending this object right here and going to scene, or it's extending to another class. So you have this constructor with a super key, scene 1. To create, adding the text, input on pointer down, going into scene 2. I assume there's another scene. Yeah, here we go. So you have your scene 1. This is everything that's happening in scene 1. Then you have your scene 2. So these are different classes. You have this JavaScript file, this JavaScript file, and this JavaScript file. Now these we haven't talked about at all about. But so you have your index.html. As you can see, this is the bare bones. This is like your building blocks to making it show up on a web page. As you can see right here, you have your game, which holds your game state. You also have your configuration right here. So if you're switching between multiple scenes, you don't want to have a game state on each one of those scenes. You want something that is going to be outside of it and maintaining the this global object constantly. So that's why it's in its own, you know, game JavaScript. So in each one of those, it can pull that value from inside each scene. So the score set 0, but like once you start adding up scores and you go into this one, let's say you have 10, well, when you move to 3 or 2, that score will still remain the same in the game JavaScript. So all your global variables, it's good to have it in here for your game. And then you have your configuration settings in here with all your scenes, your 1, 2, and 3. And then your game itself that's being produced. And then in here, so as you can see, your scripts are called right here and your game JavaScript. So everything on here, this is basically telling the web page, okay, this right here, is going to be playing inside here. This script right here is your phaser. It's basically saying, hey, I'm reaching out to phaser, and we're using it in this web page. So that's what these are, and we'll break that down later whenever we're creating our actual first application in the editor. So there is only 6 here, so we could probably go through these kind of quick. So let's start with the first one. Alright, so first thing is we're going to refactor the code from Learn Phaser. One major change is we're going to implement is the inclusion of JavaScript's class syntax. Each class will represent a scene and contain the familiar preload, create, and update. So each one's going to have this basic look. Going to refer to these functions as methods since they're functions that belong to a class. Below is a sample template, so that yep, these are all methods. And then the first thing you're going to see is the constructor method that is used to create and initialize the scene object. Okay. Inside the constructor method, we call super, which calls the constructor of the phaser scene. So what is the super is doing is this new class that we're having, like this box, is extending to this box right here. So it's saying, okay, super, which this super keyword is actually referring to the phaser.scene. So it's super, and it's getting a key. It's entering the key of this right here, of this class, which is example scene. Well, we would actually have scene 1 in here, I believe. And these right here, preload, create, and update, as you can see, are now methods. Notice the lack of function keyword. In order for Phaser to know about this class, we'll also need to change the config object. Okay. So we'll create our class right here then. So instead of having it in separate scenes, are we going to be creating it? Okay, we'll see what happens. I believe we're going to create each class in here, but usually when you're creating classes, you want it in different files. So let's go ahead and create a new class. So we'll call this class. So this is like our box full of stuff for an item called game scene that extends the phaser.scene class. I believe in here we'll add ourselves a constructor method. So we'll do that and create a super with the key of game scene. Believe. Okay, so get class game scene extends phaser.scene. Okay. We have our constructor. Okay. Constructor reference inside the constructor method, call the key. Oh. Game scene. Okay. Game scene. We'll now move all the preload, create, and update functions into this game scene class. Okay. So we'll take the create with all its stuff, take the update. Okay. Take all, oh. So we'll take all of these methods, all these functions, all of this, and we'll put it inside here. So we'll take that, the update. We're not going to have a function create anymore. It's just going to be create. And then preload, we're going to take that out as well. So we also need to kind of bump this up a bit. Okay. Bump this up a little bit. Gotta bump this up a little bit. Gotta make sure to know that, hey, this is all underneath this scene right here. So now this is all under the class called game scene. And in order to do this, we also need to add it in here. See? Now we can add multiple scenes to our game. Just to make sure, took out update, took the function from create and the preload. So now these are all functions in here that belong strictly to this class. So now they are now called methods. Okay. So create a new class called game scene. Add a constructor method, a preload. No response. I sure did create a class. It's right here. Class extends phaser dot scene. Pretty well. Create. I did create this game state class, so why is it? Ah. We didn't put that in there. Ah, man. See, little tiny syntaxes can really muff up your whole game. Scene property, delete the scene's current value and replace it with the game scene. Yep. Already did that. Alright, see? So now we can extend multiple scenes. So, okay. Let's go to the next one. So now using the class syntax and fixing, we can add another class that render a start screen for our players. Okay. So now this will be the game scene. Then we'll have one, I guess, that will be your first scene. So we'll do the same thing. Add class name start scene. So class. So this is another class or another box we're making for our scene. And then we will make this the start scene. Extends phaser. Phaser dot scene. And then we'll make our constructor. This is what pretty much makes our scene for us. Okay, so super calling the phaser scene and adding this to it. I believe game key start scene. Okay, and then at the beginning we'll have to add text. So this isn't the first scene, so we have to add stuff to it. So we still need to add the create. And then, you know, you have your creates and the updates. So this is why you have all these things in separate classes, because everything starts being jumbled together. It's hard to keep track. So your start scene. Let's do a this dot add dot text, and it wants us to let's do a 200 by 200 again, or we can do 180 by 200, and then add the text. So wait, click. Click to start game. Okay. All right, so we did that, and then, so if we go to the config all the way at the bottom to our configuration, it's saying that the game scene is the first one to start out, and we don't want that. We want it to be the start screen, the start scene. So we'll go ahead, put a comma, so it should do the start scene and then the game scene. So what should start out on here, as you can see, is the click to start game. But let's I don't know if it'll keep it though, so I don't want to go ahead, but we can change this to black. I'm sure it'll do it in the next lesson. But now let's do this at 180, 50. Kind of want this more in the middle if possible. 120. Run that. Okay, that works. So click to start game. So click the config and scene property. Scene to start of the rate. Okay. Okay, so it's probably gonna say it can't detect it, but I know we're doing all right. All right. Okay. Well, it did detect it, and we're all good. So let's go to the next one. Now, this is the scene transition. So what we want to do is right here. So when I say click to start, yeah, see, it already changed everything and did everything for me. So I didn't have to. So add your code below. Let's go ahead, and this is an input on, pointer up, and when that happens, so this dot scene dot stop, I believe, would be the what we have as start scene. And then what we want to do is then this dot scene dot start, and then we will start the game scene. Now that's what I believe should happen. So if we do this, click to start, and then it starts. Cool, there we go. And then when it starts here to restart, I believe it should go back to the call this dot scene. Yeah, I did that already. So you have two options. You can use the start scene and then go into the game scene, and then if you know, the player dies, you can have it come back to the title screen, and then you can keep doing that. And then if you want, if you get tired of it, you can just, you know, import a, you know, a text or something like that, that when the player clicks on this text, it could come back to the start. All right. So that's done. So now we are looking to put this in finally separate files. So you have your index, what we talked about. You have your game file that has all your stuff in here. Paste in only the game scene. Start scene. So the game right here has all of our stuff in here, as you can see. And we need to separate all of this out because it's being cluttered. See, this is the start scene stuff, this is the game scene. So let's just take all of this out right here and put it respectfully where it belongs, in its start scene. So there's that. So now everything in the start scene is finally in this. And then you have everything in the phaser scene, or in the, the game scene. We're going to take this out, and we'll put this in the game scene right here. So all of our everything that goes inside the game is now in here. Everything in the start screen is here, and everything for the game that's a global will go in here. Now I believe the game state would still have to reach out to here, like how it is on the game scene right here. The game state, like this game state right here, would probably have to extend out into the game JavaScript or file in order for it to still be active. So now that we have all these in here, down in the body element, this is what everything that's displayed on the web page is going to be in your body. You have your scripts that you'll be adding in here. So we'll be adding the script src, and this is what we're going to add as we need to add our start scene, right? And then we will add this tag right here. Alright, so we're adding our start scene, and then we are going to add our game scene. Cool. And then we will close this tag. Alright, now we have all of our scenes added to the game. We have our start scene, we have our game scene, and we have our game JavaScript file. Sure did. We had the start scene, the game scene. Oh. No, that should be right. So Ah, so you can't just add those. That was my bad. You have to explicitly provide the file name of what it's going to be. You can't just put the name in here. You also have to extend the file that it's putting in here. See? And then it starts. And see, game over. You can restart. But see, every time that the bug hits, it's generating our score. And click to restart. Now, as you can see, this might be a little slow, and it's hard to dodge out of some, even if you are understand what's coming down. So you can actually increase the velocity of that, as we learned in the earlier in the session today. So, all right, we copied the entire code for that. Copied the entire code for the game scene. All right. So now we've learned about transition to go back and forth if need be through here, through the this dot scene dot start and the scene dot stop. So we have now, at this point, created our first game. So now this would be reviewing just the lessons that we've learned. Start a scene, add multiple scenes to the configuration scene, and we know that the order that we put them in determines where we start out and what going next, and making sure those are all within the configuration, so that way we can reach out and say, hey, we're going to this one or this one. Now, the thing I did realize is this global variable is extending to these other other classes. So that's something to keep in mind. We'll see how that transitions when we actually go to our text editor. But so far, if anyone has been like following along, we've now been able to, keep score. We've now been able to create static groups like platforms. We've been able to make groups like the enemies that were coming down, and creating multiple enemies. We've been able to, see how fast we want our guy to move, our player to move. We've also determined which way to move, and I'm sure hopefully later on we'll understand the physics of jumping and being able to incorporate that into an actual platformer. And I'm sure, like some other games where if you're jumping on platforms and stuff, the camera will move around that player, so that way you follow along with them while it's moving. But at this point now, we have gotten the very foundations on how to fully create a game. So that's awesome. And we should be able to, in here, in the game scenes, so whenever we preload, we can actually add our own sprites, and we can create those within sprite editors and create animations. So when a button is pressed, like if you're going right or left, you can then make certain animations go the way you want it to. And if you stop, then you'll play this animation like an idle, so left or right. So it'll actually become like a fully immersible game by the time you are fully done. And you gotta think that's really cool to be able to do things like that. As far as we came to not really, not knowing anything. So up at this point, we've essentially wrote all of this code, everything that's in here, we have written, except for, you know, very minor things like this HTML. And, you know, this really isn't that hard. You just have the HTML. It's telling that the language is, you know, in English. You have your head elements that with the metadata for char set is basically saying, hey, this is using like the American like char set or English char set. Like it's telling the computer, hey, this is what it's using. Your title. So your title is the bug dodger. This will actually show up here, like in your tab. So that, like how you see learning game development with Phaser.js, this is your title. And then in the style, this is where all your CSS comes in, like your canvas. This is the width of your game. This is 450 pixels. So this is how width looks like right now. And yeah, so, and that's the end of the head, and your body is everything that's displayed on the web page. So, you know, later on, if you guys want to learn kind of like web development, or, you know, you guys want to pursue that more and be able to start making web page and doing that sort of stuff later on, we can actually start doing the free code camp that I highly recommend anyone that wants to really start on the world of, you know, data manipulation, or, you know, responsive web development, using React, you know, learning more in JavaScript on how to, you know, make interactive web pages like here on this site, you know, be able to click buttons and go to different, you know, different pages, you know, a whole different kind of set. You know, the freecodecamp.org provides all those resources to help get you started. And, you know, if we have enough people that are interested in doing that, you know, we can go ahead and we can, you know, get free certificates, you know, for completing these with real world projects at the end of it. So, you know, anyone that wants to start that journey can go right ahead. And if anyone wants to do these things together, we can certainly do that as well. So, you know, I'm, you know, kind of open to ideas on that. And that not only helps you guys, but that also helps me, you know, get more projects under my belt and more, you know, learning experience at that same time. And once, you know, it takes approximately like maybe 6 months to get that done, because there's so much material and so much projects and so many certificates that are offered to you. By the end of the time that you're done that, you could get your first programming job as a junior developer, or, you know, starting out your career. And I know a lot of people who have actually gone through that and ended up becoming successful and landing their, you know, their job, and have really enjoyed it. But right now, you know, we're learning game development. We're gonna go ahead and, you know, after we're done with Phaser, we'll start moving on to learning how to make the sprites for it. So that way, whenever we, you know, we can actually take everything that we create and put that inside of our games, and actually, you know, you'll have a full-fledged game that you've created, and you can say that you own. And I think, you know, that's amazing, and, you know, something like that you can be proud of. So that's it for this session. I believe we'll have to see what the next is. Okay, so the next thing we're going to do in the next session will be introduction to animation and tweens in Phaser. So that's going to be great, because now, since we've been using static sprites this whole time, not being able to move, now we'll be able to have them do what we want them to do using sprite sheets. So you'll be able to run right here, and then whenever you're not, you know, not running and doing idle, it'll switch between, you know, certain frames. So that way it breathes that life into your game. All right. Well, I think that about covers it. I appreciate everyone that decided to stick with me uh, and join me tonight. Um, and I'll post when the next session will be. So I hope you guys have a great night. Enjoy the day tomorrow, and I will catch you later. Peace.